Hi everyone, in this video we're going to discuss our diagnostic test. So for the first question, it is a complex number questions. So we given here Z1 is equals to 2 plus I, Z2 is equals to 1 minus 3I. Firstly, our task is going to express this operation in the form of standard form. Then find your modulus and argument for this W and express this W in polar form. So your W is obtained by the conjugate of Z1 times Z2, then Z1 divided by the conjugate of Z2. So substitute our conjugate of the Z1. Conjugate means we are going to change the imaginary part only, which means that this will be 2 minus I. Then for Z2, we substitute in 1 minus 3I. So from here, we want to test you whether you can do your multiplication or not. Continue for Z1, 2 plus I, and divide by the conjugate of Z2, which is 1 plus 3I. So this part, we want to see you can do the multiplication. And this part, we're going to see, do you know how to do the division on complex number? So when we have division on complex number, what we need is we need to rationalize the denominator. How to rationalize the denominator? We need to time with its conjugate. So the conjugate here will be referring to the denominator here, 1 minus 3i. So the conjugate of 1 plus 3i will be 1 minus 3i. So we time with its conjugate so that we can rationalize the complex number, where complex number time with conjugate, you will get a squared plus b squared. It's a real number. You can get a real number at your denominator. Then we can divide it. All right, then we continue. For this part, we expand 2 times 1, 2. 2 times negative 3, we get negative 6i. Then I times 1, negative I. And then negative 1 times negative 3, we get positive 3i squared. So for this part, we perform our division where complex number time with its conjugate, a squared is 1. B is 3, so 3 squared is 9. And numerator will be expand like usual, so 2 times 1, 2. 2 times negative 3. And then I times 1. And then I times negative 3i, getting negative 3i squared. And for I squared, we have to simplify it as negative 1. Then we simplify here into our standard form. So 3 times negative 1, negative 3, plus 2, we get negative 1. We do the real part first. Imaginary part, negative 7i. So this is our standard form after multiplication. And what is our division in standard form? So negative 3 times negative positive 3 plus 2, we get 5 over 10. Imaginary part, negative 5 over 10i. Then we simplify here, real part with real part. We get 1 over 2 negative. Imaginary part with imaginary part, so negative here. So after we done our calculation, all right, you say A, B are the real number. So means this is our real number here in standard form. Hence, we need to find out what is your modulus and argument. Modulus for W. It will be in the formula of square root of A squared plus B squared. We just need to substitute what is your real part, negative 1 over 2 square, B part, negative 15, 1 over 2 square. And you simplify, it will become 2 to 6 over 2. Now I move on to argument, where most of the students, they will do some mistake on argument. So let us refer our notes here. In argument, what is the important things and what is the thing we need to alert if when we doing the basic angle alpha for inverse tangent here, inverse trigonometry here, this part B over A should be referring to the length of opposite length and adjacent length. So it's a length, it's a quantity on length. It's supposed a scalar quantity it's not represent with your coordinate. Alright, so this A and B, just put in the positive value, not putting modulus or negative inside. Alright, and then one more mistake there will be, you are using degree. So in doing radians, in doing argument, we are set the mode in the radian. So come back to our questions here. When I want to know my argument, I draw the argand diagram. This is real part and this is imaginary part. To know that which quadrant for my complex number fall in. So real part negative 1 over 2, imaginary part negative 15 over 2 is will be quadrant 2. So in quadrant 2, argument, it will be theta. So you look at here. In quadrant 2, it will be pi minus alpha. Argument Z, theta is pi minus alpha. So here, theta here will be pi minus alpha, where the alpha referring is your basic angle, shift tangent, which is your B, 15 over 2, A is 1 over 2. So this is the common mistake that student will be easily getting wrong here, getting not correct. Then you just need to press your calculator in radian mode. So definitely they will give you 1.637 radian. Make sure our decimal is more than 3 significant figures. So what I give here is 4 significant figure. Alright, then lastly, after we finding this argument, the question asks us to write it in polar form. So W, polar form, start with modulus Z in the bracket cos theta plus I sine theta. Okay, so this is our working, and then we want to highlight here. So normally I can see student will be like writing like this. Eventually, I understand that you try to make it positive, but our idea is our inverse tangent, the inverse tangent with it, the value with inverse tangent in it, this is a non-negative value. So when I say non-negative value, so which means that we just put in positive. So that is the part that I want to highlight, where most of the students will writing this and doing in the degree form. Alright, so take note of that. So hopefully next time you do your argument, will be writing incorrect for this working. Alright, so hopefully you didn't do this. Then we go for the next question for indices. So for indices, most of the students still will losing the mind when they want to doing the indices. So every time you get to the indices question, this thing you need to come up with within your mind here. You have 3 options here. Easy to say, level 1, level 2, level 3. When we're doing indices, the first concern always will ask you, can it be single or not? This one. It's not doing the base first. Can we see the operation here? Can it single or not? Which means that indices in indices between is times or divide, or it is adding or minus. So the operation, if you're adding and minus, times and divide, this can be single. But if you're getting the indices, like our question, this is one indices, this is another indices, you can see indices operation is in minus, you should bring the question to this option level 3. So they are in the case of not indices, not single, not become single. So you cannot just thumb and then doing whatever you want. All right. So it not doing, it won't solve the questions. So we need to let our indices, getting the quadratic, factorize, and then sub back to find your indices. All right. So what do we need to let here? We'll be letting out the simplest indices that we can form from here. So 2 to the power 2x minus 1 means the simplest indices we can find here is let m equals to 2x. Alright, so for this all power here, we need to simplify. So we simplify, it will be 2 to the power of 2x times 2 to the power of negative 1. Alright, power add up together. You can see power add up together, which means it is in the operation, times. Simplify it so that I can let the 2x here. Then 9, and then 2x times 2 power of negative 2 plus 1 equals to 0. Then continue. So here we have 2 to the power of x power 2 divided by 2. And this is negative 9 over 4 times 2x plus 1 equals to 0. Then only we can start let m equals to 2x. We get this one is m squared over 2 minus 2 over 4 m plus 1 equals to 0. So when we're getting quadratic, alright, so make sure you simplify your quadratic, not letting your quadratic in fraction, alright, then not letting your quadratic in negative, because normally most of the students, 99% of the students, they will use calculator and helping out to factorize. So calculator only will show up 1 over 2, negative 1. But when you put it in bracket, it doesn't make sense with your working from here. How do you get this? So you can see 2m with m, we didn't get m squared over 2. Therefore, when you're getting your quadratic, before you're going to press your calculator to help you, make sure your quadratic here, make it a whole number. So here we will times 4. Time with 4, we will 2m squared minus 9m plus 4, then equals to 0. Alright, then only pressing your calculator to get your quadratic here. So our answer, when I press calculator, I can get 1 over 2 and 4. So factorization 2m minus 1, then m minus 4, then only can make yours working rationally. When you have this quadratic in the bracket, when I expand out is this quadratic, when I put in the bracket is 2m and m squared. So most of the students, your mistake here is you never, or you forget to simplify your quadratic equation, then you just press your calculator straight away. Alright, that will make you losing your marks and then missing a concept that showing out that you definitely do not understand what is quadratic and factorization. Alright, so factorization and quadratic equations supposed to be equal backs each other here. Alright, come back to question. When you have m equals to 1 over 2 and m equals to 1 equals to 4, then I substitute 2x is equals to 1 over 2, 2x is equals to 4. So we can make it to the same base, then we equal the power to get 1. So this is how we get the value of x. So for value of 4 also, we can make it to the indices base 2, then we can find out the power equal x equals to 2. So for indices case, alright, we no need to check answer. Every x, every number for the x, when you put in the power here, they can accept. Alright, you put in power negative, you put in power positive, you put in 0, the indices can be working, no problem. So when we're doing indices, we no need to waste the time to check whether this answer. So there is not such thing about checking answer in indices equations. All right, so bear in mind, don't waste your time there. Then I move to the question 3. When we have modulus both sides, all right, so when we have modulus both sides, we exchange our modulus in the symbol of square root and square. So it will be square root x minus 1 square less than 2 square root x plus 3 and square. So when I change the symbol modulus to the square root and square symbol, then how we going to solve this? We're going to square both sides for this inequality special form. All right, special form. So squaring both sides, square root and square cancel, leaving out x minus 1 square. 2 square give us 4. And this is x plus 3 square. Then we expand. Remember, when you have something expand, it will be a square, and then 2ab, and then b square. So it will be x square, 2 times x times negative 1. You will get negative 2x, and then this b square, we're getting positive 1. So 4, expand this bracket, x square, 2 times 3 times x, 6x, then 3 squares, 9. Expand some more, and we get a quadratic inequalities. To solve quadratic inequalities, refer to your notes 2.2 about inequalities for quadratic. So arrange everything into the left hand side. Let your right hand side is 0. Then your quadratic must be simplified. Let the quadratic to be positive before you factorize. Then you graph it. You shade the region, whether you want the positive region above the x-axis or negative region below the x-axis. So for this, when I move it to the left hand side, I get negative 3x squared. Then we get negative 26x and negative 35. So less than 0. Because of negative, we simplify, we divide by negative. Change sign. Then only we can do factorization correctly accordingly to your quadratic equations here. So you can get 3x plus 5 and x plus 7. So you can see quadratic and its factorization always tally back. So 3x squared, 3x times 3x. This is 35, 5 times 7. Yes, they are equivalent. Alright, equivalent quadratic with its pair of factorization. So after I factorize, we're going to draw the graph, shade the region. Finding the roots, let the left hand side be the smaller value, which is negative 7. The roots of negative 5 over 3 at the right hand side. Then for the region, more than 0 means the region above x-axis. So when the region above x-axis for this graph will be this side and this side and this side. So 2 regions here. So after we shade it, we can write our answer in set solution. The question asks us the set of value of x. So set solution, our x is x less than negative 7. Alright, so this is our answer. This is our answer. This answer is at the left hand side for this from this value of negative 7, which means that this x is always less than negative 7. Then continue, we have another part of the answer, this x. Okay, referring to the answer, this x is at the right hand side for this root, which means that this region will be having the value more than negative 5 over 3. Alright, so that will be the set of value of x for this quadratic. Then we move on the next question for equation of the log. So equation of the log also a weak question student cannot manage, where you do it whatever you like. So when you're doing logarithm, come up with your mind must be have these two way only. Okay, option 1 and option 2, two-way. So two-way, starting from the same base. Look at the question, they are already same base. Secondly, can it be single or not? So which means that what is going to see here, we see within log and log, what's the operation? If the operation is plus as minus, it can be single. If your log and log, between log and log, you see got division, means the log cannot be single, you need to let the m to be the log. Alright, so look at the questions here. I have a log here. So eventually it's just an operation between plus and minus. So plus and minus, which means that my questions here is go to the level 1 only. So it can become a single log. So how to make it single log? We can move this plus log 9, 10 minus x equals to 3 over 2. So log plus log become a single log. And the item it brings will be in multiplication together. Alright? Jadikan sekali, and then apa yang dia bawa, darabkan. So eventually when you get your single log, what do? You equal the item, means you unlock. You equal the item, you solve it, and remember you check for validity. So you unlock this, you give your x plus 2, 10 minus x, 9 to the power of 3 over 2. Simplify this. Alright, expand, simplify this. This is a quadratic, so 10x minus x squared plus 20 minus 2x. So this is 27. Simplify, negative x squared, negative 2. Negative 8x and then plus 7. So again, our quadratic in negative cannot directly go and factorize. Simplify your quadratic. Make sure your quadratic is positive when you are using calculator. So we divide by negative 1. Alright, so this is negative. So when we simplify our quadratic, what do is factorization. So you can press your calculator. X is what? X is 7 and 1. So your factorization, x minus 7, x minus 1. So how do we check the answer? Not checking left hand side or right hand side. Just have a look, is it valid or not? Because in the log here, we cannot simply put any number of x. If the x is negative, log negative, it will be invalid. Alright. So what we need to do is we need to make sure our log here, the value x that we find here, didn't match this bracket negative. So 7, you put here 7 plus 2, 9 positive. So 10 minus 7 is positive. So this is valid. This answer x equals to 7 is valid. So check by validity, writing up valid or not. So x equals to 1, we put in 3, okay, positive valid. And then put in here 10 minus 1, 9, positive, okay, valid. So this log equation have two valid x. Alright, so that's all for this. Thank you for watching.